As we walk over into this arena, the primary objective is material testing and development. So in this area, you'll find a host of ovens or environmental chambers. Each of these pieces of equipment are regularly maintained and calibrated per ISO 17025 standards, and they are unique. So plastics, their properties are time and temperature dependent. How they behave at say -40 and how they behave at say 200F are fundamentally different. In order to understand what the ramification is to your particular product, you need to test it. These particular ovens are sat here because they do not only temperature, but they also can do humidity. A lot of what we do is in the medical space. And one of the catchphrases in the medical space, or the testing that is required, is called extractables and leachables. So if I'm designing a medical device that's going to be patient contacting, you need to be very aware of what is in that material and test it thoroughly to ensure nothing comes out of that that's going to be deleterious to the person as they're using it. This allows us to artificially age and expose different polymers at different rates and at different humidities to fundamentally understand if there's an issue from a toxicology or extractables and leachable perspective. One of the unique things about PSN is that we're very opportunity driven. So none of this was built in a day. We added this capability over the many years of doing this, and we're about a 20-year-old company. Recently, we've gotten into the medical space, and that has led us into needing to do some toxicology type issues. So we added a bio lab. We won't go in there because there's pieces of equipment running, but we have the capability to do cultures, to do fundamental chemistry for biotoxicity issues. It's a dedicated room for that. And behind it is a chemical storage lab which houses your autoclaves, which houses our acid digester for some of the pieces of equipment inside of our analytical lab, which we'll get to in a few minutes. I will mention also that this lab, per ISO 17025, is on a backup generator, so that if we're in the middle of running one of our tests for our clients and we have a disruption, there is no disruption to the test that's actually running. This room has its own separate HVAC system, has its own separate room to run gases and fluids as needed, so that we can, from a safety perspective, kind of isolate anything that might be questionable. If we walk into this room right here, this houses some of our rheological equipment and additional testing capabilities. These pieces in the corner, they're called QUV, which basically is a weatherometer device. So if you're trying to make a polymer or test a device to be used for outdoor exposure, again, this simulates outdoor exposure to sunlight and humidity changes throughout the day. These pieces of instruments right here are rheological equipment, so capillary rheometry, melt flow rheometry. They're critical to understand the performance of how the material is going to melt and shear so that we can understand it from a processing perspective. And in the back, Dave's working on some measurement devices, but he's sitting next to an impact tester. So notched izod impact testing is a destructive test that we offer to characterize some of the impact performance of the materials. We also have drop dart, which we'll maybe set up. Dustin's now moved from working on some earbuds over to our ventilator lab. So this is, since COVID hit really, we've been very active in breathing devices and ventilators. And there's a test in the ISO world called 18562, where it basically tests the fundamental materials of construction inside ventilators to assure and certify that none of those materials have anything bad in them that's ultimately going to impact the human body. So in this arena, we expose breathing pathway devices inside custom ovens that we've designed and built and accredited, and then we collect those organic molecules in small devices called Suma canisters, plug that into mass spectrometry equipment that in the future will be housed right over here on these tables, but currently is our analytical lab, which we'll touch on in a moment. But this is a dedicated lab for ventilators and other breathing devices. This is our material test lab. And inside of our material test lab, we have a host of different capabilities to be able to thoroughly characterize materials, whether it's physical properties, whether it's mechanical properties, rheological properties, or analytical properties. It's very rare that you actually actually find all that capability in one company. There are material test labs, but typically they're dedicated to mechanical and radiological or analytical or things of those natures. It's very rare that you find it in the same under one roof. Eric over here is working with a tensile tester. Our tensile tester is equipped with a laser extensometer. It is a state-of-the-art technology to be able to thoroughly characterize and accurately capture displacement, crosshead displacement, and actual displacement of the test materials that he's using. We find that fundamentally understanding the materials and being sure that we have accurate representation of their properties allows us to be more effective when we do design and analysis in the other areas of our business. As we move over here, both Rigwed and Ashland are working on our TA thermal suite of equipment. So we have a TGA, thermal gravimetric analyzer. We have a TMA, thermomechanical analyzer. Those are pieces of equipment that characterize the material for unique applications. TMA is typically coefficient of thermal expansion. TGA essentially ashes off the material and will tell you what's in there fundamentally, because everything will flash off at a particular temperature. So if you're working with a polymer that's 30% glass filler or something like that, it will tell you what that level is. On the other side, we have a DSE, which measures enthalpy, entropy, essentially energy to melt a particular plastic. Plastics goes through a series of transition periods, and fundamentally understanding how that material behaves can answer a lot of questions, whether it's failure analysis or whether it's a fundamental development of a particular material that you're trying to create for an application. So if it's a bioresorbable, or you're trying to replace it with something more classical, you need to understand what those properties are. DMA, Dynamic Mechanical Analyzer, is a very diverse tool that can characterize materials from negative 40°C to positive 300 plus. It is equipped with a liquid nitrogen tank behind it to be able to achieve that atmosphere, and it can do high frequency testing on very small samples. So oftentimes in the R&D arena, we work with clients who may only have a pound or less of material, so we don't have the luxury of being able to mold injection molded samples, and we have to work with a finite amount of material. We also have the equipment and tooling to be able to make that work for them as needed. This room houses our inductive coupled plasma mass spectrometer, so ICP-MS. This is a very unique piece of equipment that you don't classically find readily available at a lot of labs. I'm only aware of a few in the area. This essentially measures heavy metals down to the parts per trillion. Heavy metals are important for a variety of reasons. Fundamentally, if I'm growing tomato plants in my backyard and I'm using metal pots, and I want to make sure nothing harmful came out of that metal pot into my plant that I'm going to consume. So we use this in the food and pharma industry. We also use it in the plastic industry because there are a lot of metallic components that are used as catalysts, and you want to make sure that those catalysts are fully consumed in the reaction so that you get the final material that you think you get. Very sensitive machine, has its own room, dual exhaust, heating and cooling supplied to this room separately. In that same vein is a full suite of PerkinElmer equipment that we're going to walk into this analytical lab, so come along with me. Both Udesh and Kevin are two of our analytical chemists working in this arena, and in this arena we've got several pieces of equipment. We've got GCMS. We've actually got two styles of GCMSs in the back here. One's a FID, and the other one has a thermal desorption and a mass spectrometry. Thank you very much. We have an HPLC, high pressure liquid chromatograph, next to Udesh over here in the corner. That is used to measure a variety of organic components inside of a material. And then we have a LC triple quad. On a basic level, when I show people this lab, I'll tell them that it has the ability to fundamentally understand the DNA of anything organic and a wide array of different levels of accuracy. So some of the higher end pieces of equipment will get you in the ballpark. This room will actually tell you what seat you're sitting in that ballpark. So, unique offering you don't classically find in a lot of places. Speaking of that ballpark, FTIR, if someone sends us an organic material and they're not quite sure what it is, we run a quick scan. It'll kind of tell you what family of materials you're working with, and then if we need to fine tune it from there, we have the capabilities to be able to do that. In this lab, there are about 10 different folks that work in here. There's a few chemists that share in there, a test lab manager over here, a few more chemists over here, a couple engineers that work over here, all dedicated to testing, development that ultimately support the rest of the business. And then you'll find some tabletop workspace, some moisture analyzers, a few other pieces lying around that we need to use for our particular clients. And sample storage on its own, lock and key. It is custom that we hold on to our samples for 6 months after the test is run, just in case a client needs to rerun it for a particular reason.